Welcome to the second lecture video, chapter 4. And so this one we're going to talk about cost estimation methods such as account analysis, and we'll talk about the high-low method as well, and we'll briefly talk about linear regression. Okay. We say over here with account analysis, we're going to say this is a common method, a common cost estimation method, common cost estimation method that uses judgment to estimate costs. Okay, so it's not the scientific method, but it's a pretty common method just because it's pretty easy to do. Okay, so if we look over here, look at our example. He says, assume that the cost of producing 2,000 units of our barcode reader was $265,000. The first thing that we would have to do with account analysis is do a detailed breakdown of this 265. What are the costs that comprise this 265? So let's say that we do that, and let's suppose that the costs are, we have direct materials equal to our $130,600, and we have our direct labor of $32,400, and let's say that we have utilities equal to $7,100, and let's say that we have rent of $22,000, and let's say that we have depreciation of our $72,900, and then we add up all these, you get that $265. Okay? The first thing that we'd actually have to do is go through and classify these costs. Well, this is the first thing we do, is get the cost breakdown. The second thing is we go through and do is classify these costs as variable, fixed, or mixed. So we know that direct materials costs are variable, direct labor costs are variable, utilities costs, those would be mixed. And let's just assume, let's say that prior experience says that it's a mixed cost, so it has some fixed and some variable. Let's say that it's 50% fixed and 50% variable. Okay, and again, we would be getting these 50-50 from prior experience, from judgment. Rent, let's say that we know that's fixed, and depreciation, we know that's fixed. So what we can do is we can come over here, is we can calculate our variable cost per unit and our total fixed cost. We can say, here's our variable cost per unit, so they call it component cost. This is our direct materials, direct labor. So we come over here and we say, here's our direct materials, our direct labor, half of our utilities. This gives us a total variable cost of $166,550. We can divide that by the 2,000 units. Remember, if you look on the prior page, it said that that cost breakdown of 265 was for making 2,000 units. So this gives us a variable cost per unit of $83.28. Okay. So now what we can do is we can say, and well, before I go on, let's also look at our fixed costs. Half of our utilities, our rent, and our depreciation gives us our total fixed costs. So now what we want to do is say, at 2,500 units, what's going to be my total cost? Well, in order to do this, we have to use the assumptions that we know hold true for variable cost per unit and fixed costs in total. We know that variable cost per unit stay the same. So as we move from making 2,000 units to making 2,500 units, this number will stay the same. You might be confused and say, well, why is that? Because I'm divided by 2,500. Will this number go down? Well, you forgot to increase this number. Because remember, if I go from 2,000 units to making 2,500 units, I'm going to have more materials. I'm going to have more labor, and I will have more utilities, which will increase this number, and I'll divide by 2,500, and I'll still get 83.28. Okay? And then as I move from making 2,000 units to 2,500 units, my total fixed costs will also stay the same. So I can use this to figure out what will be my total cost for making 2,500 units. And what I can do is I can take $83.28 times 2,500, keep my variable cost per unit the same, multiply it times the new level of activity, 2,500, and then I can add in my total fixed cost of $98,450, and then that would give me total cost. Okay? So if we look at this, this is what we would get. This is how we can do cost estimation with account analysis. So we can say Our variable cost per unit stays the same, $83.28, multiplied by the new level of activity, 2,500, and that gives us our total variable cost right over here. And then we can add in our fixed costs, which we know will stay the same as we move from 2,000 to 2,500 units. Total fixed costs will stay the same. This will be our total costs. Okay? And if we know what we sell the price of our barcode reader, we can figure out profit because we know our costs. And that's something we'd want to know. Okay? The problem is this is pretty subjective. I mean, how do you really know that half of the utilities are fixed and half of the utilities are mixed? That's pretty subjective. Okay? And so some different managers could arrive at different conclusions because they have different assumptions. Okay? The other option that we could do is the high-low method. Okay? So we could use the high-low method, which kind of relates to some of the stuff you probably did back in high school, where you had to calculate the slope. Remember that? And you took rise over run to calculate the slope, and then you could use that slope, which then becomes the variable cost per unit. Okay? And we know that will stay the same. So you look over here at the high-low, the first thing that we're going to do is we're going to find the high and the low level of activity. And then we're going to find the corresponding cost. Okay? That relates to that high and low level of activity. Okay? And then we're going to use that to calculate rise over run. Rise over run would be the slope. Okay? So we say over here, what's my high level of activity? 500 units. What's my low? 350. What is my corresponding cost at 500 units? 5,500. What is my corresponding cost at 350 units? 4,750. When you do the math, you get $5 per unit. Then what I can do is I can back in to figuring out what my fixed costs are. Okay, what my fixed costs are, because remember, we have total, this is our total mixed cost, right? And this is right over here, our total mixed cost. That is going to be divided into total variable, right? And then total fixed. So if we know this number, and then we can figure out total variable, we can back into figuring out total fixed. And that's what I'm doing right over here. So basically, remember, what we can say, if we do it algebraically, we can say total cost equals fixed cost plus variable cost. So therefore, I could just use algebra. I can move this over here, and then I can move the total cost over here, and I would get fixed cost, therefore, equals the total minus the variable cost. Now, this is total variable cost, right? Total variable cost. How do I get total variable cost? By taking the rate, my variable cost per unit, times the level of activity. That gives me my total variable cost. So what I'm going to do is I'm going to choose the cost at either the high or the low point. It doesn't matter which one. It has to be the high or the low point. And then I'm going to subtract out my total variable cost. So I'm going to say right over here, I'll choose the high, 5,500. And what would be my total variable cost at 500 units? Well, it's going to be my $5 per unit, my 5 times my 500. My $5 per unit times my 500, which is my level of activity. So what that will give you is your fixed cost, which is $3,000. Okay? Now we can use that to answer the question of what will the company expect in terms of total cost at an activity level of 700 units. Well, we know variable costs per unit stay the same, and fixed costs and total stay the same. So what I can do is I can go my 700 times my 5, which equals my 3,500, plus my fixed cost of 3,000, which is going to give me $6,500. That would be my total cost at 700 units. And I can do the same thing over here for my 300 units. I can say my 300 times my 5 plus my 3,000, okay, which when you do the math, you get $4,500. Okay? Now the problem with the high-low is that you're only choosing 2 data points. Okay? You're only choosing 2 data points. Now this is not such a big deal because we only have a few data points, but if we had 20,000 data points and we want to do high-low, that's going to cause a little bit more of an issue. Now the other problem with high-low is that you're choosing the high and the low, which by definition are abnormal. They're the outliers. So you're choosing the outliers, to come up with an average variable cost per unit, some measure of central tendency, does that really make very much sense? Okay, that's the weakness. So on this page, I have some extra problems. You may want to pause the lecture video and just tackle these really quick, and then we'll move on to talk about least squares regression. Okay. All right, so let me go ahead and take a look at these. Sales salaries, commissions are 10,000, 80,000 units are sold, 14,000, 120,000. So I put my cost up in my numerator, my 14,000 minus my 10,000 divided by my 120 minus my 80,000, which gives me 0.1 B. Then I can come over here and I can say, what's my fixed portion? So I can say, I can choose my high or my low. I'll choose my high, 14,000 equals my fixed cost, which is my unknown, plus 0.1 times at 14,000, that means I did 120,000 units. And so when you do the algebra, get A is the right answer. Okay? Talking about least squares regression, and this is something where I will have a lecture video showing you how to do regression in Excel. This is probably the best method to do cost estimation. And so what regression does is it finds the line that best fits the data. And the line that best fits the data would be the one that minimizes these errors. So this is a line, and when it's not right, when the data point is not right on the line, that's an error. Now the problem is, that's a positive error, that's a negative error. That's a positive, that's a positive, that's a negative. And so if you were to just go through and find the line that gives me the smallest number of errors, if I summed up all these errors and found the line that gave me the smallest number of errors, this is positive, this is negative. They could cancel each other out. So what I do is I square the error. And by squaring the error, it becomes positive. So what regression does is it finds the line that minimizes the sum of the squared errors. And by doing that, you find that line, you therefore get the slope, which is the path which will be the path coefficient. That's the slope of the line, which is our variable cost per unit. And then it gives us the intercept right here, which is the fixed cost. And then if I have the fixed cost and the variable cost per unit, I can then do my y equals a plus bx. This is my slope. This is my fixed cost. Multiply that slope, variable cost per unit, by any level of activity to then give me the total cost. Okay? So least squares regression would probably be the best way to do this. And again, I'm going to show you how to do that in Excel in a subsequent lecture video. I really don't see a reason why you wouldn't use least squares regression. It just seems to me to be the easiest way, especially because you can do it so easily in Excel. Okay, if you have the data, put it into Excel, do a regression, get the answers, and then you're done. Okay. The problem is all the methods could give slightly different answers because of the assumptions underlying those methods, especially account analysis. Okay, and high-low only uses 2 data points. Least squares regression would be the best. All methods do require a linear relationship. The weakness of the high-low, as I was saying earlier, it only uses the 2 data points, and those periods of the high-low would be atypical, and you're using the outliers to develop some measure of average variable cost per unit. Does that really make very much sense? So if it were up to me, I would just use least squares regression. Okay? All right, thank you. This concludes this lecture video. The next one will start to cover cost, volume, profit analysis. Thank you.